Hey everyone, welcome back to my channel. If you ever struggled with solving the linear equations, you are at right place. Today we are diving deep into the graphical method. We will break it step by step. So by the end of this video, you will be able to visualize and find the exact solution to any pair of linear equations. So watch till in, don't skip and share with your classmates. Let's start the video.
Pair of linear equations in two variables. A pair of linear equations in two variables is a set of two linear equations that contain two unknowns or variables represented by equation 1, that is a1x plus b1y plus c1 equal to 0, and equation 2, a2x plus b2y plus c2 equal to 0, where a1, b1, c1 and a2, b2, c2 are real numbers, where ai square plus bi square not equal to 0 such that I equal to 1, 2, 3 etc. In above equation, x and y are two variables and degree of this equation is 1, so it is known as linear equation in two variables.
Methods of solving pair of linear equations in two variables. In this chapter, we learn two methods. First one is graphical method and second one is algebraic method. Algebraic method contain A. Substitution method, B. Elimination method, and C. Cross multiplication method. Objective of this: the objective is to find values of x and y that satisfy both equations simultaneously. Now look at graphical method. Linear equations represented by a straight line on Cartesian plane. Plot two equations on a graph to find the point of intersection. That point gives the solutions to the system. Types of solution and graphical behavior. First, equation 1, that is a1x plus b1y plus c1 equal to 0, and equation 2, that is a2x plus b2y plus c2 equal to 0. Now we look at consistent pair. If a solution exists, then pair of linear equations in two variables classified as consistent. For unique solution, intersection point, the unique solution represents the specific point x and y where the graphs of the two equations cross each other. Nature of graph for unique solution: the pair of lines meets at one and only one point. Now independent equations: the lines are not the same lines, they are distinct, represents independent conditions. Now a special case for unique solution: if the intersecting lines meets at 90-degree angle, they are called perpendicular lines. Now algebraic condition for unique solution that satisfy a1 by a2 not equal to b1 by b2. Now we look for infinite many solution. Intersection point for infinite many solution, that is every point x and y on the line is a common intersection point for pair of equations. Now nature of graph for infinite many solution, that is pair of lines lies exactly on top of each other. Now dependent equations for infinite many solution, the lines are the same lines, they are not distinct and equivalent to each other. Now algebraic condition that satisfy infinite many solution, that is a1 by a2 equal to b1 by b2 equal to c1 by c2. Now look for inconsistent pair. If no solution exists, then pair of linear equations in two variables classified as inconsistent. Now there is no solution for inconsistent, then intersection point, there exists no intersection point x and y for pair of equations. Nature of graph for no solution, pair of lines are parallel and never intersect to each other. Now independent equations for no solution, the lines are not the same lines, they are distinct, representing independent conditions. Algebraic conditions satisfied for no equation, that is a1 by a2 equal to b1 by b2 not equal to c1 by c2. For more clarity, look at example. Consider the following three pair of equations. First one is x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. Second one is 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. Third one is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Here we can see all pairs have degree 1 and 2 variables x, y. So these pairs are linear equations in 2 variables. Compare all equation with a standard form, that is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, where a1, b1, c1 and e2, b2, c2 are coefficient of equations. After comparison, in one of equations, we get a1 equal to 1, b1 equal to minus 2, c1 equal to 0 and a2 equal to 3, b2 equal to 4 and c2 equal to minus 20. In two of equations, we get a1 equal to 2, b1 equal to 3, c1 equal to minus 9 and a2 equal to 4, b2 equal to 6 and c2 equal to minus 18. In third of equations, we get a1 equal to 1, b1 equal to 2, c1 equal to minus 4 and a2 equal to 2, b2 equal to 4 and c2 equal to minus 12. Now make a table and write serial number, then pair of lines, then ratio of coefficient of x a1 by a2, ratio of coefficient of y b1 by b2 and ratio of constant term c1 by c2. Then compare all ratios. Then we see graphical representation which will show algebraic interpretation or type of solution which pair contains. Now first pair of lines or pair of equations, x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. Here a1 by a2 is 1 by 3, b1 by b2 is minus 2 by 4 and c1 by c2 is 0 by minus 20. After compare the ratio, we get a1 by a2 not equal to b1 by b2. Then graphical representation will be intersecting line. Algebraic interpretation for the pair of equation, exactly one solution, unique solution. Now second pair of equations, 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. Then a1 by a2 will be 2 by 4, b1 by b2 is 3 by 6 and c1 by c2 is minus 9 by minus 18. Compare the ratio, a1 by a2 equal to b1 by b2 equal to c1 by c2. So graphical representation will be coincident line and algebraic interpretation will be infinite value solution for the given pair of equation. Now third pair of equation is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Then a1 by a2 is 1 by 2 and b1 by b2 will be 2 by 4 and c1 by c2 will be minus 4 by minus 12. Then compare the ratio, we get a1 by a2 equal to b1 by b2 but not equal to c1 by c2 and graphical representation for this parallel line and algebraic interpretation is no solution. Now look at example. Check graphically whether the pair of equations x plus 3y equal to 6 and 2x minus 3y equal to 12 is consistent. If so, then solve it graphically. Now solution. Let us draw the graphs of the equations. For this, we find two zeros of each of the equations and make a table. Now make a table for equation x plus 3y equal to 6. Now we write x and y. If we take x equal to 0, then we get y equal to 2. If we get y equal to 0, then x equal to 6. Similarly, for 2x minus 3y equal to 12, we make a table and write x and y. If we take x equal to 0, then we get value of y is minus 4. If we take y equal to 0, then get x equal to 6. Now plot these points a 0 2, b 6 0
and C 0 minus 4, B 6 0 on graph and try to find intersection point.
Take a graph paper and draw vertical line and horizontal line with arrow at both end. Now mark intersection of line at center 0. Now mark horizontal line x and x dash and vertical line y and y dash. Now divide x axis with equal division of a scale 1 unit and mark positive number right side of the origin and negative number left side of the origin. Similarly, divide y-axis with equal division of a scale 1 unit and mark positive number above the center 0 and negative number below the center 0 on y-axis. Now circle point 02 on y-axis and point 60 at x-axis. Mark 02 as A and 60 as B. Now midpoint A and B. Then we will find a straight line passing through these coordinate that represent x plus 3y equal to 6. Similarly, circle point 0 minus 4 on y-axis and mark it D and meet point D and B. Then we get a straight line which represent equation 2x minus 3y equal to 12. We observe in graph that line AB and DB intersect at a point 60. So the solution of the pair of linear equation is x equal to 6 and y equal to 0. Hence we can say that given pair of equation is consistent having unique solution. Algebraic interpretation must satisfy unique solution condition, that is a1 by a2 not equal to b1 by b2. Here a1 by a2 is 1 by 2 not equal to b1 by b2, 3 divided by minus 3. Ratio of coefficient of x not equal to ratio of coefficient of y. Now look at another example. Check graphically whether the pair of equations y equal to 2x minus 2 and y equal to 4x minus 4 has no solution, unique solution or infinite many solution. For solution for this, let us draw the graphs of both equations by finding two solutions of each polynomial. In both equations, y is dependent on x and x is independent variable. So take any value of x and calculate y. Make a table of solutions for both equations. First we take x and y equal to 2x minus 2. Then if we put x equal to 2, we get y equal to 2. And if we put x equal to 0, then y equal to minus 2. Another one, x and y equal to 4x minus 4. If we put x equal to 0, then we get y equal to minus 4. And if we put x equal to 1, we get y equal to 0. Take a graph paper and draw vertical line and horizontal line with arrow at both ends. Now mark intersection of line as center O. Now mark horizontal line with x and x dash and vertical line with y and y dash. Now divide x axis with equal division of a scale having 1 unit and mark positive number right side of the origin and negative number left side of the origin. Similarly, divide y axis with equal division of a scale 1 unit and mark positive number above the center 0 and negative number below the center 0. Now circle point 0 minus 2 on y axis and name it A and point B 2 2 in first quadrant. Now draw a straight line passing through this coordinate. The straight line represents equation y equal to 2x minus 2. Similarly, circle point 0 minus 4 on y axis and 1 0 on x axis. Name it P and Q respectively. Then after draw a straight line passing through these points P and Q. We get a straight line which represent equation y equal to 4x minus 4 and an intersection point 1 0. We observe in graph that line AB and PQ intersect at a point 1 0. So the solution of the pair of linear equations is x equal to 1 and y equal to 0. Hence we can say the given pair of equations is consistent having unique solution. Algebraic interpretation must satisfy unique solution condition, and that is a1 by a2 not equal to b1 by b2. So 2 by 4 not equal to 1 by 1. Ratio of coefficient of x not equal to ratio of coefficient of y. Thank you so much for watching video. Keep practicing. We will meet in next video with other method of solving pair of linear equation in two variables. Like, share and subscribe please.